Hello, I'm audible. Hello, I'm audible. Please reply. Hello, I'm audible. Yes, okay. Thank you. Okay, so welcome everyone once again. Sorry for not taking the class regularly because I was engaged in a placement activities of the batches, and there are still many things which I have to manage. But yes, this is my priority, and I have to start it. Okay, so as you know that we have started digital part and we have finished the digital implementation of adder, and I was stuck in the last class, if you all remember, if you that we have to implement the 8-bit adder using the multiple bus, and then we have to implement it on a tool, right? That is on Xilinx ISE. So I have shown you the demo, but I was stuck because I was not able to get the exact output. I am working on it, and I will definitely get back to you with all the details. Okay. So today my planning is to start the HDL Verilog. Okay. Why Verilog? I am starting now. There is a reason. What I am planning here, I am planning to take up the digital along with Verilog. Okay, these two I want to take in parallel. Why? Because whatever I'm going to design on digital, right? If any component, it can be adder, subtractor, multiplier, divider, mux, demux, decoder, encoder, sequential, take, latch, flip flop, okay, your shift registers, counters, everything, whatever we want to design, okay, we will design along with in parallel with Verilog. Okay, so in this way, I can say your digital and your Verilog plus FPGA implementation. All three modules will be running in parallel. Okay, let's hold on. So, okay, so this is my objective. Let me start. So, see, okay. So as we know that we are part of the we are basically going through the classes which is belong to the VLSI. Okay, and I'm not talking too much about VLSI. Okay, very huge topic. There are many people in my academy who knows deep about VLSI. Okay, but what I am planning here, uh, I have to just summarize it again. We My idea is to give you the exposure of analog, then digital plus Verilog plus FPGA and programming. Okay, this is my objective, right? So this is what Vivek is taking care of it. This is what I am taking care of it, and this is what Devansh is taking care of it. Okay, so how I'm going to proceed, that whatever we are learning in digital, okay, let me make it here. Whatever we are learning in digital, for example, combination and sequential. Okay, combination and sequential circuit, whatever we are going to design with help of the Xilinx IC tool, All those combination and sequential circuit we will design with Verilog with three modeling. One is your gate level modeling. Okay. One is your data flow. Okay. And one is your behavior modeling. And sometime maybe you mixed modeling. Right. So many times, many people like you asking that, sir, I don't like programming, or sir, I'm having fear in programming, or sir, I have not done programming because I belong to very village and I was from Hindi background, or vagera vagera. There are many things, the Hindi background or any native language background, and we don't have exposure on programming. So this is the biggest challenge what 90% people from CS, from EC and EE are facing. Again, they are taking the EC or triple E because they don't know the programming. That is also one of the reason. Okay, but what is my comment here? What is my feedback here? In VLSI, whatever the IC you are seeing which makes our life comfortable, anything, either in automotive, medical, consumer, space, defense, satellite, whatever. The IC which you are basically the IC which is very active, switch on and off. Okay. So that IC, the first level of design is from this language, HDL, Verilog and VHDL. Okay. So it is very easy to learn. Why? When you know the digital. If you don't know the digital, if you are not aware of the digital components, if you are not aware of the how the components are working, how the components are taking the input and giving the output, and what is the logic behind the component, you can't frame the logic. Okay, you can't frame the logic. So from last 12 years, many people are coming and saying, sir, I don't know the programming. So I have to taught them first the digital. Once they are aware of the digital logic, then they easily learn the syntax. Then we have to learn the syntax in Verilog. And then according to that syntax, slowly, one by one program, they start learning the HDL. Okay. So this is the first time I'm on this open platform. Okay. So the way of giving training from my side on Verilog is totally different. I am touching very basic, very basic, very basic. I am not touching the very high level of syntax. Right. So high level of syntax not required now. You need to first focus on very basic level of syntax. It is a gate level modeling, it is a data flow modeling, or in a behavior modeling. You should understand what is the purpose of that syntax, and using that syntax, at least you have to make the some 5 to 10 programs. If you don't know how to make the programs, how to solve the error, you never familiar with the coding. Okay, so in VLSI front end, this is what we are taking care of it, right? Okay, so data flow, behavior modeling, and mix modeling. So in my last 12 to 13 classes, I have started talking about gates. We have solved some questions on gates, like uh, designing of gates using NAND, then designing of other than NAND and NOR, there are few more gates, right, which are acting as a universal gates. And then we have taken the adder. We have designed half adder, then implementation of half adder using NAND gates, and then implementation of full adder using NAND gates, and then optimization of both gates using NAND gates from 6 to 5 and from 20 to 9. Okay, then there are many things like I also discussed how to start working on the tools on Xilinx IC schematic tools. Okay, so today I am going to focus on HDL. Okay, so there is two way of teaching. One, directly on writing on board. Second, I should show you the some PPT. Okay, the PPT based training is also available with me, and plus without the PPT, you should start, or I should start discussing. Okay, so I will take the both things in parallel. Okay, I will not teach everything here. Okay, I will take the reference of the PPT. In that case, you will have a better understanding. Okay, so let me start with PPT first. Okay, okay. So as I mentioned here, that I'm going to start Verilog today, and I'm taking the reference of the PPT, right? So why the PPT based training I required here? Because sometime what happened, you need some reference, okay, to go through it. Maybe you miss any topic, maybe you miss any theoretical concept, so you can have a better reference from the PP Verilog. Okay. So see, I'm not going to discuss the line by line. I'm just going to summarize it, okay, for your better understanding. Okay, so I will just go through it and I will summarize for your better understanding. Hardware description language is a software programming language used to model intent operation of piece of hardware. Okay, here the line is what line? The first line is the purpose of HDL is to make the life of the engineer easy. Okay, sometimes we cannot design the hardware, we cannot think the hardware sometime. Okay, or I can say sometime means I'm just talking about very basic understanding of the hardware, right? For example, the you can say LED blinker. You have a minimum, you have a 10 LEDs and you have one switch. If you switch on, one by one LED is on. If you switch off, one by one LED is off. Then you have another switch. If you switch on, 1, 3, 5, 7. Similarly, the LED is on and similarly the LED is off. Third switch on, two LEDs on, off, on, off. So what I am want to say here, you want to design the hardware of the LED blinker, okay, which is easy to design, okay, but it take time. It take time means it will take 1 day, 2 day, 3 day, 4 day, as per my understanding. Uh, Whenever you will get a time to design the circuit using the Xilinx ISC schematic tool, okay, we have designed it. Some of our students have designed the LED blinker. Then another challenge, like the hardware design of traffic light controller, hardware design of FIFO, hardware design of, or I can say the design of FIFO, LIFO, everything in one logic, okay, or the digital clock or the stopwatch, okay. So designing the hardware of this circuit is little bit typical. It is time taken, it is complex, right? It is very complex. We have designed each and everything. We have the demo of everything is available, but the thing is that it is very time taken task. And nowadays you can't invest 3 days, 4 days, 5 days to design a simple circuit, but it is required. Why? To make the logic of an engineer. Okay, so that is the problem which is solved by the HDL. If you know the HDL, you can easily write the logic of LED blinker, FIFO, LIFO, multiplier, divider, sign calculator, anything. Okay, your digital clock, your SSD, everything. You can write it in a from half an hour to 1 hour, 2 hour, and it is also very easy to debug it. Okay, in schematic, if you have seen my class, that in last few class you can see that we have earlier we have 4 lines, then we have 16 lines, then we have 32 to 50 lines. So one problem, it will take a time, but it is required in a BTech. Okay, nowadays in the industry no one is working on schematic, but in a BTech you required because it will open your mind. Okay, so the first line, same thing, intent to operation of the piece of hardware. Hardware can be anything, right? EDA tools are computer-based software system to design very large-scale integrated circuit. Now, EDA tools are available for almost every stage of VLSI design flow. But to start with, most convert design idea is on mind to EDA tool such a way that tool is able to understand that and generate a highly optimized design implementation. Okay, so now let me again explain you. As I mentioned that you the designing of the complex hardware is a tough task. Okay, but the designing of the complex task with the help of HDL is also a tough task. It's look very easy. We write the code and design is working. No, there is a tool is required. Okay, that tool is called EDA, Electronic Design Automation Tool. Okay, the electronic design automation tool is like I can say in the two segment. One is a totally FPGA side. Second, totally on ASIC side. Okay, so I am talking about the FPGA side because ultimately we have to take this Verilog VHDL or FPGA. Okay, so Verilog and VHDL language is basically working on FPGA. Is we are going to implement the logic on FPGAs. So there is a tool, okay, which is required to convert the language, the textual information into the machine language or into the or in the form of bits. Okay, so the converting of textual information into the bits, which is not performed by us. This is performed by the EDA tools, Electronic Design Automation Tool. So you people are saying AI, AI, AI. I am saying this thing implemented 20, 30 years back. Okay, in 1983-84, Xilinx had decided to come up with the FPGA, the glue logic, that is a device, totally digital device. Now, how to work on those digital devices? You require the tools. Manually, you cannot program it. So you need a system. You have to write the code. The code you have to write on the system. You have to program it, and then you have to implement it on FPGA, and then those FPGA output you have to take out to the interface. Okay, this outside interface. Okay, so this is the line which is basically mentioned by here is that EDA tools, these EDA tools. Okay, this transfer of idea from human beings to machine is called design entry. Okay, let me explain. Okay, again I'm going to explain each and every line because you should have a better understanding of Verilog. I should not directly come to the coding. Okay, because our task is not to write a code of Verilog in few lines. After my this course, at least you should write a code at least in 500, 600 lines. Okay, not now, but you will definitely make it. Okay, if you have any questions, please. Sir, Mike Dur. Okay, Mike. Okay, any issue you are facing? Any language? Any like I am audible properly? Please say yes, no. Voice is cracking a bit. Okay. Now please tell me. Hello. Now please tell me my voice is okay. 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 I will use only one mic. Okay. So let me in next 30 seconds if because sometimes why I'm using two mic because sometimes many people have said that sir your voice is very low. That is why I started using the two mic. Okay. Please let me know if my voice is okay. better the way. Okay, thank you. So, team, boys and girls, you have to wait for some time because I need to create a story. Okay, I don't have to jump directly to the coding. I need to create a story. Then only you will get a better understanding. The writing the code is not important. Okay, you need to understand why we are writing the code. Okay, good now. Thank you. Okay, so the transfer of idea is from human being to machine is called design entry. What does this means? Okay, the design entry means in a Verilog or in VHDL. Okay, okay, in Verilog or in VHDL, whenever we are writing anything, my idea to the hardware, okay, that is called a design entry. What is design entry? I want to I want to convert my idea into the hardware. Okay, so there are many types of design entry. One is textual form, one is schematic form, and one is third party form. Third party means that this tool is different, this tool is different. Okay, so when you have a two different tool, then there is a some international format. Okay, that is also known as a design format that we call a EDIF, electronic design interchange format. So suppose that I have designed something on Xilinx, and finally the things has to come on Altera platform. So for that, the both Xilinx and Altera both are different format. Okay, they have different libraries, different file names, etc., etc. So how this thing can be transferred from here? There is another known as ADIF, Electronic Design Interchange Format. Okay, so that is not our concern. So what is design tree? Converting of idea from human being to into the machine. Okay, that is called design tree. So we are familiar with two design tree. One is a schematic, which I have shown you, and another is a coding. Okay. Okay. So see, it is mentioned here. There are two methods of design tree. One is a graphical, schematic form, schematic, and one is textual coding. Right. The graphical method includes schematic entry and state diagram, and textual method implies use of HDL, hardware description language. Okay, so graphical methods work fairly well up at certain level, right? We cannot make a 1,000 bit of counter using the graphical level. Please try to understand. 1,000 level of counter or 1,000 level of adder. Okay, that is a 100 bit adder. We cannot make with the help of the graphical. By coding, it is very easy to make. Okay, the graphical method works fairly well up at certain level of a circuit complexity, but in larger circuit, they become cumbersome and time consuming. Okay, so this is why the HDL came. If you go through about the HDL, before Verilog there was a one more HDL. In 1975, 72, 73, the HDL was invented that we call a VHDL. Okay, so the VHDL is a more older language than Verilog. Okay, VHDL here, VHDL means here, I will also teach you the VHDL, but later on, not now. Okay, VHDL, VHDL. Okay, V stand for VHSIC. V means high speed, very high, very high speed integrated circuit. Okay, very high speed integrated circuit. V for this, S for this, S for this, I for this, and C for this. Okay, so very high speed integrated circuit. VHDL is formed by Department of Defense USA. Okay, between 1973 to 75. Okay, before that there was many language. Why the HDL is so famous? HDL is famous because it is very tough to learn the different language. Okay, like Boolean, Pascal, many others, ABEL. Okay, so engineer has to learn the three, four different language and then write and perform the logic. So that is why the one common language invented that is called a VHDL. Okay, but in 19 but in 1983, okay, but in 1983 the another language invented. Okay, so I will come to that part. The 1983 the other language invented that is called Verilog. Why? Because Verilog is very easy to learn. Okay, and etc. That we will discuss. Okay, I hope this is clear. So let me summarize. Okay, let me summarize it that if you know how to work on hardware schematic, please understand, if you know how to work on hardware schematic, okay, from a single bit half adder to to 8 bit full adder, okay, and then subtractor and then multiplier divider and then make these things calculator algebraic equations geometric equations, then your LED blinker, okay, your stopwatch, your digital clock, your traffic light controller. There are many things. If you start inventing those things with help of schematic design or graphical entry, it is little bit tough. Okay, but again, till BTech you have to do that. Why? Because if you know how to make the counter, you will never forget it. Nowadays, if I go to any college and if I ask what is counter, show me the waveform. Tell me why, what happened if T is 0, T is 1. They will say, fourth year guy, they will say, sir, I have learned in second year, in third year. Sir, I don't know. Very few knows. So with the help of this tool, you will never forget. Engineers should never use the word try and revision. Please note that. Engineer, you should not say, sir, I forget, I should revise it. This is a practical work. If you are working, why you will forget it? Okay. So that is the reason this tool is very helpful. Now, HDL offers following advantage. Compact descriptions. Okay. Compact descriptions, easy to edit, highly portable, supports a high level of abstractions. I will discuss one by one. Rapid prototyping of designs, availability of extensive vendor libraries, and increasing capability of synthesis tools. Compact descriptions. Let me tell you. Okay. Okay. Compact description. Okay. That means you don't have to. Compact description means with a single line. Okay. That is a counter. If I say a counter, okay, to make a 100-bit counter or to make a 16-bit counter or to make a 15-bit counter, whatever, or to make a calculator, that is you require an adder to make a 8-bit, 16-bit, whatever. In hardware design, you have to design one by one. It is time taken task. But in Verilog, if you want to design a 4-bit counter to 400-bit counter, just you have to make a changes in vector, in buses. That's all. That is called a compact description. Okay. So that you have to make just a change in vector to 32. Okay, what is this? We will discuss. Okay. So 4-bit counter to 33-bit counter, you can easily design with the help of coding. This is called compact description. Easy to edit. In last class, we got the error in 8-bit counter, and I got today 1 hour to explore it. Still, I am not able to solve it because I am not able to solve it. Where is the error? So we have to find out the line by line the output. Okay. So there is a challenges in schematic. Okay. So, but in Verilog, if you have a line number 1, line number 2, line number 18, wherever the problem you will face, right? Wherever the error you will get, it will take you directly to that error. Here in line number 18, this semicolon is missing. In line number 18, this you have used with capital letter here, and this you have used with a small letter. So easy to edit, highly portable. Okay, if I have written anything on VHDL, sorry, in Verilog in Xilinx, I can convert into the Altera tool. That is called a portability. Okay, but the schematic cannot be converted. The schematic cannot be converted from Xilinx to Altera, or from Altera to Lattice, or from Lattice to Quick Logic, or from Quick Logic to again Xilinx. So it is not port easy to convert the hardware or schematic. Okay, schematic to from one vendor to another vendor. Then support a higher level of abstraction. Okay, you know that in schematic I have to make a 8-bit adder. I have to write first. I have to design first half adder, and with the help of half adder I have to make it full adder. Then with the help of full adder I have to make it 8-bit adder. Okay, so there are three level in. So abstraction, what is abstraction? Abstraction means level. Okay, level. Okay, so in Verilog, just with help of one operator, just with help of one operator, okay, and calling the bus, okay, bus means calling the vector, we will make the 32-bit adder. Okay, that is called a higher level of abstractions. Similarly, if there is also a low level of abstraction, that is starting from half adder, then full adder, then 4-bit adder, that I will show you later on. Okay, so both are available. Rapid prototyping. Okay, what does mean? Suppose that I have a FPGA board. Okay, I have to implement a 4-bit counter, and then I have to implement a 16-bit counter. So in my FPGA board, I have a 16 LEDs as well as switches. So I have implemented the 4-bit LED counter with help of schematic. So I have taken 4 T flip-flop, and there are many things. Okay, then converted, then implemented on FPGA. But again, I have to go and make it 16-bit. It is a healthy task. It will take 1 hour, 2 hour. But when I'm going to use with the help of Verilog, just writing, just changing the bus value, vector value, you will make a 16-bit counter. So this is called a rapid prototyping of design. Availability of extensive vendor libraries. That is I'm calling a syntax. Okay. There are good number of syntax are available in both the HDL, so that you can make the coding very user friendly. Whatever you want, however you want, you want to see the output with the help of these libraries. Okay. For example, I want my output to be transferred on positive edge, or I want my output should be transferred on negative edge. So in Verilog, you will use pos edge. In VHDL, you will use the same thing. Okay, so this pos edge is one of the library or syntax. Okay, increasing capability of synthesis tool. So I don't know you guys are aware of synthesis or not. So synthesis tool is basically a tool which converts the textual information into the hardware, okay, which you can easily see. I will show you the demo. Okay, I will show you the synthesis of every design, whatever we have designed the in in our classes. Okay, so please try to understand. Don't run. Okay, मन में आप सोच रहे होंगे कि सर कब कोडिंग स्टार्ट करेंगे, because this is a one time I have to explain. Okay, so this is very required. Unless until you don't know why we are going for coding, or why we are learning the schematic design. Okay, what is the difference between those? Then only you will create an interest in you. Okay, guys. So let's take up. Hope I am able to understand you. My voice is okay. My voice is okay. No disturbance. Okay. Please. Yes, sir. Okay. Thank you. All good. Okay. So, what is the limitation of HDL? Okay. What is the limitation of HDL? It is clearly mentioned here. No support for analog behavior. Okay. Analog behavior means it is there nowadays, but analog behavior means you can't, uh, you cannot see the output like this. Okay. That line means no support for analog behavior or output in terms of like this. Okay. What is basically this logic is basically going inside the FPGAs. Okay, so FPGA is purely digital device. Need to learn the coding styles that ensure the synthesizable result. The very important points. Okay, you cannot write anything. Okay, there are two types of syntax. One is a synthesizable syntax which generate the output from coding to hardware. That is called a synthesizable syntax or synthesis. There are few syntax who which does not generate any hardware. Okay, which does not replicate into any hardware or any gate level hardware. Okay, that is called non-synthesizable. But those syntax is help you to understand the simulation. Okay, which help you in understanding the simulation. Okay, so you need to learn lot of syntax. Okay, lot of syntax like task and function. Okay, like FSM modeling, like loops, like case, like if. There are many high beginner level to expert level of syntax are there. Okay, support for hardware concurrency and time frame are two main features that distinguish HDL from other programming language. Very important. Okay, very important. The first interview question in every people asking why we are using the HDL over C. If C is very oldest language, why Verilog is used or why VHDL is used? Because C is executed sequentially, but HDL is executed in parallel, concurrent, right? Concurrent. Okay, this is the best part of hardware description language, and this is exactly what we required in hardware description language. Okay, next. Now, history of Verilog. You should feel very proud, or may you should will feel very proud, very proud that this Verilog language is using by across in every part of the world. Either you go to Austin, UK, USA, Australia, New Zealand, Italy, Rome, wherever you will find a VLSI company front end design this Verilog. Okay, so this Verilog, okay, there is difference Verilog and VHDL. Okay, VHDL is also used, Verilog is also used. But as per my understanding, in India, VHDL is used for in defense, okay, to develop the protocol FPGAs. Okay, but Verilog is also used, right? But why Verilog is so famous, so familiar? Because Verilog is connected with the verification languages. That is why Verilog is so famous. Okay, so I will not go in deep about Verilog, Digital Verilog, etc. Okay, but there is also a verification language is also in the VHDL also. Okay, so I'm talking about why you should feel proud. We should feel proud because this language is designed and developed by an Indian. Name is Dr. Prabhu Goel. this is the interview question. I was always asking if anyone is coming and saying, "Sir, I know Verilog." I asked, "Who was the founder of Verilog? Who has developed a Verilog?" Silent, zero. No one knows. 10 out of 9 say, "No, sir, I don't know." Because why? Because you start reading the book from the first chapter or second chapter. You never start reading the book, the index or other things. Okay, so Mr. Prabhu Goel, along with his colleague Phil Murphy, and the 1983, the Gateway released the Verilog hardware description language. The Gateway Design, the company known as Gateway Design, has designed. Okay, and Verilog simulator also. Simulator where basically you code it and run. Okay, in 1989, Cadence bought Gateway Design. Okay, the company known as Gateway Design. And in 1990, Open Verilog International OVI was formed to control the language specification. So this is the proprietary language of Cadence. Okay, this is the proprietary language of Cadence design system. In 1995, the Verilog was reviewed and adopted by the IEEE. Okay, so this is the history of Verilog. So recently an updated IEEE standard is 1364 2001, etc. Okay, so 2001 is the year, 1364 is syntax, libraries, total number of like whatever things are available. Okay, I'm not much sure, but I will check and let you know. Okay, so this is about the Verilog. So two great people, scientists or say engineers, Mr. Prabhu Goel and Mr. Phil Murby. Prabhu Goel sir is I think from IT. I'm not remember, but I think he's from IT Kharagpur or IT Kanpur. Okay, that I will check and let you know. Okay, so this is about the history of Verilog. प्लीज इसको नोट कर लो अच्छे से, इंटरव्यू क्वेश्चंस में है, पूछा जाता है अगर हमारे जैसे लोग मिल गए। ठीक है, हम यहीं पे डिसाइड कर लेते हैं कि बच्चे को पता है या नहीं पता है। ओके, नेक्स्ट। ओके, सॉरी थोड़ा सा टाइम लगेगा बिकॉज अगर इफ आई डोंट एक्सप्लेन यू ईच एंड एवरीथिंग वन बाय वन, ओके, then the story will not created. Okay, so now let's start this very easy things. Basically this PPT I have designed or I have created or I have prepared with the help of book Samir Palitkar. Everyone please bought PANIT Samir Palitkar. This is the book, please purchase it. Today only I have ordered again because I have ordered so many times, but many times my students have taken or maybe I have not asked, they have not returned it. Okay, so today also I have ordered three books. One is again Maurice Mano with a new version, Verilog and VHDL. Good book, Maurice Mano. Both Verilog and VHDL is there. Again is Samit Panitkar, the hardcore Verilog book. And one more book, maybe you are not aware of it, that is Synthesis book. Okay, so the most common approach for solving any design problem is divide and rule. So this is not a rule which basically before independence the Britishers follow. Okay, so don't compare that. Okay, so let's go through it and find out. We divide top block into the sub block unless we reach at cells which cannot be further subdivided into basic design elements. For example, if you remember, if you're attending my class, 8-bit adder. Okay, so 8-bit adder we have started with gate level, XOR, and make it half adder. Half adder, to use 2 half adder, make it full adder. Use 4-bit full adder, make it 4-bit adder. And use 2 4-bit adder to make it 8-bit adder. Use 2 8-bit adder to make it 16-bit adder. Okay, so this is what line is saying, divide and rule. So decide the which flow you want to start. You want to start from top to bottom or you want to start from bottom to top. Okay, there is a figure I will show you. As shown in figure, we generally follow this top down approach during the design process, but while implementing our design we start with basic unit cells. We have example and or not flip-flop and build up bigger block, that is bottom to top. These blocks are further used to build up bigger blocks until we build top level block. This is called bottom approach, bottom to up approach. So a combination of both top level and bottom approach is used. Okay, let me show you the this next slide. This is basically okay. This is the slide basically. So cells, that means your component level, gate levels. Okay, then use of some gates you have made this cell, use of some cell you have made this, and then basically using of these three cells you have made one module, using of these two cells you will make one module, this, and then finally top modules. Okay, so basically this is called your, this is bottom to up. Okay, so this approach basically people are following. Even we have followed the same thing in a schematic design also. Okay, same thing we have followed in a schematic design. Okay, so this was our 8-bit adder. Suppose that, then this is level of, I'm just taking of level. This is of a full adder. Okay, this is all of your half adder, and this is your gate level. Okay, this is how we have followed. Okay, so depend on basically how you are following up. Okay. Okay, now let's start. This is your first Verilog program of half adder, but yes, I will explain. Okay, I will take up in very different way, so you don't need to worry. So this is the first Verilog program. That means this is the code of half adder. Okay. Uh, okay. So before starting the Verilog, let me divide. Actually, I have divided a Verilog in three different: beginner, beginner, intermediate, and advanced. Okay. So generally with beginner level, if I say, I'm telling you as per my understanding and what I'm following. Okay. So beginner, here we are covering your gate level and data flow. Okay. That is with the help of gate level and data flow. If you have the basic understanding of, if you have a basic understanding of the hardware up to your counter, shift register, okay, you can design the any counter, any shift register, or any type of multiplier circuit, divider circuit, adder circuit, full adder circuit with the help of these two modeling. Okay, so gate level modeling is very important. Okay, then in intermediate we start with behavior modeling. Okay, we start with the behavior modeling. In behavior modeling, we generally take care of few things like your conditional statement, for example, if and case. Okay, so in intermediate, we took care of the how to design the all combinational and sequential circuit with help of if and case. Okay, and in advanced modeling, we basically take care of like designing of the circuit. Okay, the big circuit where you cannot think of the hardware, the complex circuit with help of FSM task and function, etc. Okay, so in my class or with me, we are not working on those circuits or those syntax which are used for the verification. Okay, verification means you're for this basically there are two things: design and verification. Design means article design, Verilog and VHDL, 100% synthesizable circuit. Every output should be converted into the gate level netlist. Okay, so whatever you have designed that you have to verify with the system Verilog and UVM, that is called a verification. Okay, so design and verification are two different modules. Okay, two different domain, design and verification. Okay, so we are worrying about the design part. So this is what, and I have decided to give you the exposure on Verilog till here. Okay, I can't guide you this part because something you have to keep. Okay, but if you know how to use or how to design the Verilog, design the any circuit with help of gate level data flow and if case, that means it is sufficient. Okay, so this is very important. Okay, I will teach you up to here. Okay, I will teach you up to here. Okay, this don't comes under this type of initiatives. So let's start now writing the code. Okay. But why is VHDL still used while Verilog exit? No, Verilog not exit. Who said Verilog exit? VHDL is used. See, in India, I'm talking about India. So India, there are two types of product development. One is for VLSI companies. One is VLSI companies. They are designing the circuit. They are designing the ICs with the help of Verilog. Okay, and further it's used. And in defense, if you go in defense, okay, the all I actually I started my career with defense dealing the project. Okay, we are basically I'm basically FAE in one of the FPGA company, okay, known as Xilinx, and I was working on behalf of Xilinx in Avnet. Okay, so my job is to basically help the scientists to get or to design the logic or whatever they are thinking to design on FPGAs, so field programmable gate array. So what at that time, 12 years back, okay, from 2014, 2004, 2014, okay, or I can say just 22 years back, 2004, 2014, 10 years, I saw that every scientist, 9 out of 10 people are working on VHDL because VHDL is very strong and very robust language. Okay, it is tough to learn because of many high quality syntax are there. Okay, but many scientists are using VHDL. Verilog, I think now the whoever the joined recently know the Verilog, they started working on Verilog. Even in my company, OJS Technology, many engineers who are deployed from Pine to OJS, everyone is knows Verilog. So they are using both language, Verilog and VHDL. So VHDL is not exist, my dear. You cannot say that VHDL is exist. It is still available. In India, it is still available. Okay, so let's start. Uh, Syntax. Okay, what is module? What is folder? Okay, so let me. Okay, so gate level modeling. Now I'm going to start a gate level modeling. Gate level, gate level modeling. Okay, so before starting the gate level modeling, let me tell you the syntax first. Okay, syntax means how the Verilog start and how the Verilog end. Okay, so Verilog start with keyword module. Sorry, it is on a small letter. Module, start with keyword module and end with end module. Okay. So start with keyword module and end with end module. Inside this, what you have to write here? Inside this, you have to define your input, your output, your wire information, okay, and all the basic syntax required for data flow modeling and behavior modeling. Okay, behavior modeling or gate level modeling. Okay. Okay. So you have to start with keyword module and end with keyword end module. So between this module and end module, you have to write or you have to define the input, output, wire, range, gate level modeling, the how you are calling the components. In data flow modeling, how you are calling the basically the operators with help of assign statement, and in behavior modeling, you have to call the always, initial, and then all the condition statements like if, else, case, FSM, task and function, etc., etc. Okay, so this the were two things, module and end module. इसी के अंदर आपको सब कुछ लिखना है, इसके बाहर कुछ नहीं लिखना है. ठीक है, so this is what you have to write, right? Okay, so I'm going to start. The first layer modeling is called gate layer modeling. Okay, let's start gate layer modeling. So what is gate level modeling? This is an interview question. Okay, what is gate layer modeling? Gate level modeling is a modeling where you call the components. Okay, so interview question. If you go for interview will ask, what is gate level modeling, my dear? So gate level modeling is a modeling. Here we call all the different components. Either it is a user defined or either it is available in a library. We have to call those components and we have to uh, connect with the help of wires to get the desired output. Okay, so you can say a gate level is a design or it is a type of modeling. Is a modeling where I will call, okay, where I will call the components, okay, components in terms of or ability of terms of user defined. User defined means I have defined something, okay, I have designed something and now I will call the my design in another design, that is called a user defined. Or cells, or I can say the gate level, the basic libraries like AND or NAND or, okay, or basic libraries. Okay, I'm writing you so that you better understand. Okay, so gate level modeling is a modeling where I will call the components in terms of user defined or basic libraries and connect it in such a form to get the desired output. Desired output. This is what. Okay. For example, I have to make first half header. Then with the half header, I will make a full header, and with the help of full header, I will make a 2-bit full header. The best example. Okay. Sorry, I forget to mention one thing here. Test bench. The test benches. Okay, the test bench is the real purpose of the test bench is you can start from anywhere. Okay, you can start from anywhere, right? So test bench is required. Okay, so I will tell you. Okay, so why I am teaching you this Verilog so that finally all the design is we have to take up on FPGAs. Okay, so once things will design in Verilog and VHDL, then sorry in Verilog and schematic, then I will show you how to work on FPGAs. Okay, so this is so I will take an example of half adder. Then with the help of half adder, I will call my half adder to make a full adder. And then I will call my full adder to make a 2-bit full adder. Okay. So this is the best example of gate level. Right? Okay. So half adder. So as I mentioned at gate level, you should know the first major requirement in gate level is you should know the components, you should know the hardware, you should know the hardware of your design. Okay, for example, if it is a 4-bit adder, 8-bit adder, you should know how the things are basically connected. Okay, the best example is that you maybe have read the microprocessor, microcontrollers, okay, in your microprocessor book, computer architecture. You have seen the lot of components are designed like ALU, accumulator, etc., etc., right? Your uh, memories, okay, I don't remember right now. Okay, so different blocks. Okay, so all those different blocks are basically connected with help of gate level modeling, or you can say a top level modeling. Okay, so what is basically a top level modeling? In every company, okay, every group writes the different block, the coding of different block, and then there will be a one top level senior guys, senior teams who take the block from every group and merge it. Okay, so that is called a top level design. Okay, this is why required. Why this is required? This is very important. Without this, you cannot merge. Okay, every time you cannot write, you cannot mix the different specifications. Okay, because the input and output is totally different of within one block. Okay, so that is why this top level module came in picture, because you have a different blocks, and the output of this block is going to the input of this block, and the input, when it is going to the another block, it's processing and giving the different output. Then that different output will goes to the block of any other, sorry, the output of those block will go to the input of another block. Okay, for example, what is basically a top level? Okay, I'm helping you to understand why it is required. Okay, suppose that this is your block 1, you have block 2, okay, you have block 3, okay, you have block 4, then you have block 5, you have block 6, okay, and then you have one big block and the output is coming, block 7. Okay, so different blocks are there. So suppose that multiple inputs is coming here, this is going to here, this is also going to here, from here this some output is coming, this output goes to this is also goes to here, this goes to here, this goes to here. Okay, and then finally the output is coming like this. Okay, and then you have a seven out. Okay, so here one team is designing this block, another team is designing this block, another team is designing this block, okay, and another team is designing this block. So here output is become the input of this block. Here this output becomes the input of this block. Okay, so my dear, this is basically called top level, and this top level is also known as the gate level. Okay, but why it is called a gate level? Because in starting we will learn calling the gates, calling the gates. Okay, okay, but those gates will definitely give some output. So with the help of those gates or those particular block, we can use that block and two other block, three block, and make another logic. Okay, so calling of those blocks and connecting with the gate level modeling or connecting with the method of gate level modeling is called a top level modeling. Okay, so this is what basically we are going to do it. Okay, so half header, full header, 2-bit full header. Using 2-bit full header, you are making 4-bit full header, and using this 4-bit full header, you are making 8-bit FA, etc. Like this. Okay, I'll take one more example of sequential. Okay, like gates, from gates we have made latch. From latch we have made JK master slave flip flop. From JK master slave we have made T flip flop, and from the T flip flop we have made the 4-bit counter. Okay, so this is also one of the application. Just this is a sequential application. This is your combination application. For example, here gates, half header, with help of two half header you make full header. With help of two full header you make 4-bit header. Like this. Okay. So here we will design the each components. Okay, and then we will merge it. We will connect it. That is called a top level model. Okay, let's start. So half header. Okay, so team, I will use the same circuit which we have used in designing the schematic. All new, all those who are new here, please go through the previous 13 classes. Okay, or previous 8 to 6 classes. There I have designed how the gate is implemented. Sorry, how the half header is implemented from half header to 8-bit adder. Okay, so just to make it similar, just to make it connected, okay, just to make it similar, just to make connected, we will use the same circuit to design the circuit of our 8-bit adder or 4-bit adder with help of gate level modeling. Okay, so if you remember, we have used like this. Okay, we have used the clear logic. Okay, we have used the clear logic like this. This is my clear. This is my A. This is my B. Sum and CM. Okay. Why we have used this AND gate after and before and after? Because we want to control our design. Okay, we want to control our design. We want to control our design so that I should reset it at any point. I should reset at any point. Okay, I have a control on each and every line. That is why I have used this clear. So every signal will pass from AND gate and will finish it here. So whenever I will give 0, the output will always be 0. Okay, that means all the signals will be 0. So whenever I will want my circuit to start working properly, I will make this clear from 0 to 1. Then it will start properly. Okay. Now let's start writing the code in Verilog. So this is our first code. Okay, guys, this is our first code, first Verilog code. We are going to write it. HDL. Okay. So as I mentioned, I will start with keyword module, and I will end with keyword and module, right? So it is not required to write it here. In the last, you can write it. So as I mentioned, you have to define the input and output first. So what is my input? With A, B, and clear. What is my output? Sum and Cout. So module, give the module name, half header underscore clear. Okay. Now bracket. Now you have to write, you have to either call first time output and then input, or input then output, or output input output input. Anything you can follow. But please remember, if whatever the sequence you are following, you have to follow the same sequence every time, and you have to connect the logic. You connect your inputs or output in same form. Output input output input. If you are following this, then you have to create every other component in same form. Okay. If you are using output then input, then all your components should be designed in same form. All input then input. If you are connecting, if you are making the circuit or making the design first input then output, then all your logic should be designed in same form. Input then output. Okay. So, but I follow here first output then input. Okay. First output then input. Then what is my output? Sum Cout. What is my input? A, B, and clear, and semicolon. Okay, this semicolon is required to terminate it. Okay, now you know that your sum and Cout is a output, but tool don't know. Okay, tool is totally under your control, right? Tool don't know, so you have to define it now. You have to tell your tool that sum and Cout is my output. Okay, it can be anything. You can write X, Y, P, Q, R. Then are you able to understand that what is the X? No. With sum you understand. Okay, you only understand. Okay, sum is my output. But you don't understand, but tool don't understand, right? This sum is the output. Tool क्या देखेगा? Tool देखेगा just one variable, name. Okay, so you have to define, you have to write it like this, output. Okay, one more thing important, Verilog is a case sensitive. Okay, case sensitive. Verilog is a case sensitive. Output. Okay, so if you are using capital letter S, then you write the capital letter S. If you are using the capital letter S here, a small letter S here, then it will give a error. Okay, sum Cout. Sorry, semicolon done. Because you have only two output. Okay, then you have input A, B, and clear. Okay, A, B, and clear. A, B, and clear. Now, very important. Because the second important thing is that we have to define the wire. What is wire? The intermediate signal between input and output is called wire. The intermediate signal between input and output is called wire. That means the line which is not connecting directly with input or directly with output. Okay, so there is some gates, right? So here, see this line. This line is not connected to input, and this line is not connected to the output. So this is called wire W0, W1. Similarly, this is also your W2 and W3. So this is called wire. Okay, clear 0, clear 1. Okay, so we have to define wire W0, W1, W2. This is comma. Okay, W3. That's all. Okay. Now you have to call the components. Okay. So as I mentioned, these are the gate level components. Okay. These are the gate level components. Basically, these are the libraries. Okay. These are the libraries which is available here. These are the libraries which is available here. So what I will do, I will call this library one by one. So what is the syntax of calling any library? Gate name, syntax. Okay, then instance name means we have to define it, give some name, and then output, and then input 0, input 1, etc., and so on. Okay, so this is a syntax. So what is the gate name here? This is by gate number 1, 2, 3, 4, 5, 6. Total 6 gates are here. Okay, so I will call one by one all gates. So let's call gate number 1 is my AND gate. So small AND gate. Okay, now this instance name can be anything. Okay, anything combination of alpha and numeric. So you can take anything, like I'm calling N1. You can write P1, P2, and what is the output of this gate is W0. What is the input of this gate is A and clear. A and clear. Semicolon. Then second gate, this one, and 2. What is the output of gate number 2 is W1. Input is B and clear. Okay, now this is my XOR. Small L3. What is my output of this XOR is W2. And what is the input is W0 and W1. W0 and W1. Semicolon. I am deleting this. Okay, maybe we have to write it here. Okay. Okay, now what is this? AND. Okay, N4. 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 The output is, sorry, N4. The output is W3. The output is W3. And the input is W0 and W1. Okay, then you have this last N5 and N6. Okay, then again AND gate. N5 output is sum. Input is W2 and clear. What is clear? This one. This one is clear. And then again and see N6. 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 Right? And output is C out. And input is W2 and W3 and clear. Sorry. W3 and clear. So guys, if you by mistake, if you have written here W2 and here W3, or if you change the position of clear to B or clear to A, if you have the multiple inputs or outputs, then you will definitely get a logical error. Okay, you will definitely get a logical error. So while designing the top level block diagram circuit coding, you have to be very sensible, very sensitive. Okay, if you are not, then I am 100% sure you will be wasting your time in solving the or in identifying the problem. Okay, so this, and then in last and model done. Okay, so this is the coding, simple. Okay, you will definitely in future classes you will see a lot of things. Okay, this is a simple coding. Now I will call this half adder and to make a full adder, not now, in next class. Okay, calling this half adder and making the full adder, and calling those full adder and making the 2-bit full adder, and then calling those 2-bit full adder and to make a 8-bit adder. Very easy task. Okay, but this is again this top level modeling is, I can say, is a complex. Here you are not basically making any logic. Okay, in top level or in simple data flow, you are not making any logic. The main logic part is behavior modeling. Okay, 99.99% are people are using the behavior modeling. Okay, so if you are really fond of Verilog programming, please don't stop it here. Okay, if you are in first year, second year, third year, please note before internship at least you have designed the circuit or some code at least in some 1,000 lines. Okay, कुछ बड़ा बनाओ, 1,000 लाइन का कोड बनाओ. Okay, I am staying sector 62 Noida. Near around me there are many colleges. Okay, and I am having my R&D company, OJS Technology. But unfortunately, people are coming for the internship, asking for internship. We are a FPGA based company, but when we go through their resume, we never find that they have done something on FPGAs. Okay, so my idea is to build a good community on FPGAs. Okay, I should taught you how to make the different interfaces with the help of Verilog and VHDL, starting with LED, SSD, LCD, UART, keypad, VGA. Okay, then ADC, DAC control, ADC, DAC control, Ethernet, memory. There are many things. Okay, but let's see how much we can do. Okay, so if anyone had designed these things, then we can call the company for your placement drive. Okay, we can call the company for the placement drive. But yes, we don't have a people like this. Everyone is running behind the software. Yes, because you need a job, you don't want a career. So to make a career, please note you have to give time. Out of you have 24 hours, cut down 8 hours. You have 16 hours. Out of 16 hours, if you are pursuing BTech first year, second year, third year, fourth year, you have to start giving at least 3 to 4 hours daily to learn these things. If you are totally passed out of 16 hours, at least 10 to 12 hours you have to give. Then things will come closer to you, right? Your company's job will come closer to you. Start thinking at logic level, debug it. Don't take the help of ChatGPT. Don't write the code with the help of ChatGPT or with the help of any Google. You can take the reference. You can see how they are basically using it. Use your own logic. If you're not able to make the logic, okay, break it in different part. Okay, break it in different part and then start it. Many people will face in making the logic with help of is they start with the if case, because they are not aware of the syntax, how this syntax is basically working. Okay, so I will help you, I will guide you that what program you should write to build the logic. Okay, to develop the logic. So this is not an easy task. Okay, don't run, पेशेंस रखो एंड तभी आप आगे बढ़ पाओगे. Okay, so engineers are known for their patience. Okay, patience is very important. If you don't have a patience, nothing can be converted. If you have a good patience, you will develop the good maturity. Okay, so this is all from my side, all my dear. Please keep working, happy learning. Again, be disciplined, be focused, make some schedule, start working on it, do it regularly, and count it how many hours you have done it. Okay, don't study one thing for 1 hour, 2 hour, or sorry, for 1 week, 2 week. Divide your learning in every week. Okay, in this way, you will be in touch with your subject. Okay, so this is all from my side. Thank you, everyone, and Jai Hind.